Hello, everyone, and welcome to today's webinar, Playing to Win, Strategies for Accelerating Materials Innovation in Turbulent Times. My name is Rachel Darasek. I'm the VP of Marketing and Product Strategy at Lux Research, and I'll be your host for today. Our presenter is Ross Kozarski, Research Director, who leads the materials team here at Lux. Ross, tell us a little bit about yourself.
Thanks, Rachel. It's great to be here, and thanks to all of our attendees who've joined us today. By way of a quick background, I'm a chemical engineer and materials scientist by training, and spent the early part of my career developing and scaling electronic materials products. I've been with Lux for just about 8 years now, and where I direct and run our materials research group. I should also mention that while I currently live in San Francisco, I'm originally from Philadelphia, which will become a bit more relevant as we weave in some lessons from the American football season into this presentation, which I think will be particularly fun, as I know you, Rachel, like many of our Lux colleagues, are based in the Boston area, and fair to say, still some hard feelings between our respective fan bases.
We're not going to get into that here, Ross. We do still have Tom Brady on the Patriots. Some may say he's the greatest of all time, but that's for another discussion. Today, we're talking about the turbulent times in materials innovation. So let's switch over to that. And I would agree, from what I hear you and the team talk about in materials innovation, these are turbulent times indeed, as it says in the webinar title. The approach to tech innovation, which most of us refer to as the ubiquitous innovation funnel, hasn't changed much in the last 15 to 20 years. And I think that's the case whether we're talking about internal R&D or open innovation. However, the environment surrounding the tech innovation funnel has really changed tremendously. So these are kind of rhetorical questions, but can you think of a time in your professional life when there was more information, and you can see some of the sources of information on your screen, but fewer insights, or when change occurred as rapidly as it does now? Expectations just seem to accelerate by the day, but there aren't the additional resources to keep up with it. If there's anything I've learned over the years in becoming a parent and a manager, it's this: I can't do it all. I definitely need some help. At Lux, our clients include a virtual who's who of global Fortune 500 innovation companies focusing on physical industries. And our clients confirm that these same themes of information overload and accelerating change are playing out in the world of technology innovation, and even more specifically in the materials and chemicals space. So the million-dollar question is, how do you meet these challenges head on? How do you keep tabs on the vast amounts of information? And that could be information that's within your company or external to your company or industry. How do you extract only what's important from all that information and then find the time to conduct in-depth analysis, both on the technology and on the business side, on only the topics that matter? And you have to do all this so that you can make the informed recommendations and investment decisions that you're being asked to make to do your job well. For most of us, if any of you are like me, we don't do it as well as we'd like. And here at Lux, we can understand how frustrating that can be. That's why we dedicate our business to answering the key innovation questions for our clients: the what, who, and when of innovation. What is about what technology or technologies you should prioritize. The who is about who you should work with, whether that's startups, large and mid-sized firms, and/or research centers. And the when is about when to act. We use advanced analytics techniques such as data science and machine learning to track all the information. We curate the data based on expert domain knowledge, and then we pair it with analyst insight to help you make sense of it all. Ultimately, we help our clients drive growth through tech innovation by making the right decisions faster. As a demonstration of this, let's turn our attention back to Ross, who's going to give us the Lux take on some intriguing opportunities in materials and chemicals. As a side note, during the presentation, if you have any questions for Ross about the presentation or about Lux in general, enter them into the Q&A box on your screen. And at the end of the webinar, we'll get to as many of the questions as we can. Ross, over to you.
Great, thanks, Rachel. And as my title suggests, the bulk of this presentation is going to focus on how to successfully navigate the current innovation climate and drive commercial success from materials technologies. Essentially, how to win despite contending with a challenging market environment. But in order to build the framework for that analysis, we'll first distinguish what it means to play to win versus playing not to lose. And that's exactly where I'd like to start. So as I mentioned earlier, and in the spirit of the start of the American football season this past weekend, I'd like to begin by reminding everyone, particularly Patriots fans, of how the last season ended. In summary, this smiling gentleman, who most people have probably never heard of a year ago, and perhaps some are not familiar with even today, coached the team that beat the defending champions, led by this overrated coach and this over-the-hill quarterback, perhaps many of you are familiar with. So here, yes, I am talking about the head coach of the Philadelphia Eagles, Doug Peterson. Now, taking a step back from this interesting triumph by my hometown Eagles, it's actually worth noting that just a few weeks before the result happened, many thought this was going to be impossible. And the reason for that is just before the playoffs started, the Eagles lost their starting quarterback. So for those not familiar, the quarterback is essentially the most important player and the leader of the team. They lost their quarterback at the end of the regular season to injury just before the playoffs started. So what did the coach do? Well, he could have played it safe. He could have mostly relied on his defense in order to minimize the Eagles' chance of losing, but instead he chose to play to win, instituting one of the most aggressive play calling strategies in years. And it's really worth noting here that it wasn't just that the Eagles were playing with guts. They actually applied data science and analytics to their in-game strategy to optimize decision making. Those that watched the game may also remember that in what was arguably the most important play, the Eagles' backup quarterback, who normally would be the one throwing the ball, actually caught the ball in somewhat of a trick play, which turned out to be the winning score and the difference between winning and losing the championship. So why am I talking about this? Do I enjoy gloating and rubbing salt in the wounds of Boston and Patriots fans? Absolutely. But more importantly, and relevant for today's webinar, I believe the Eagle strategy here serves as a very useful foil for today's chemical and material companies, who also find themselves in a difficult situation. And as I'll argue over the course of this talk, have for the most part adopted a playing not to lose strategy, which to be frank, I think is unwise. So that, of course, brings us to playing not to lose. And to be fair, there are legitimate reasons why many materials companies have adopted such strategies. And they're mostly related to the difficult market conditions they find themselves in. So as many of you know, particularly I'm sure many on this webinar and likely grapple with on a daily basis, the chemical and materials industry currently faces some pretty challenging macroeconomic headwinds. And there's a number of factors contributing to this that I'll go through briefly here. First, the enormous growth in emerging markets like China of the past 2 decades has been slowing down. Second, new players from these emerging markets have entered the space, and the resulting additional supply has increased competition and capacity. And finally, low oil prices, combined with projected slowing and ultimately decreasing demand for oil in the transportation sector, has pushed major oil companies downstream. So the net result essentially here is that you have slowing demand, increasing supply, and thus eroding margins as commoditization continues to permeate more and more specialized areas of the industry. Right? And if that wasn't challenging enough, to make matters worse is an apparent lack of truly disruptive materials technologies with meaningful commercial consequence, right? So for instance, several of the hype darlings of the past decade, like carbon nanotubes and graphene, have failed to live up to expectations. Their commercial reality far from matches the initial hype. And new emerging materials, for instance, bioperformance materials like spider silk and nanocrystalline cellulose, have continued this trend of commercial disappointment for new platform materials technologies. For instance, the 4 companies I've listed here, Celluforce, Boltthread, Spiber, and AM Silk, when we spoke with these 4 companies in 2016, all told us that they would be launching products in the next year, but now we're well into 2018 and there still have been no confirmed successes to date. So what have chemical and material companies been doing to cope with such difficult conditions, right? Well, so the main thing that they've done is to try to get bigger, as evidenced by the massive M&A activity, both successful, planned, failed, still in progress in the space in recent years. So this suggests that many believe the key to minimize the damage here can be achieved through economies of scale. Though I have a major concern with this approach, and it's that such playing not to lose strategies seem to prioritize cost cutting achieved through accounting innovations over true tech innovation. The other big risk here is that in an environment dominated by synergies of scale and cost cutting, companies actually become even more vulnerable to activist investor campaigns. And with that as background, it's actually no coincidence that in the same time period, M&A activity in the space has grown, so too has the number of activist investor campaigns. And what's really interesting is that the data actually shows historically that companies who are able to fight off activist campaigns actually perform better on average than those where the activists have won. Right? So that's pretty scary stuff, right? And to be honest, if we're being honest with ourselves here, this is bad, right? This is really bad for long-term innovation. If you think about it, by focusing on short-term profits at the expense of long-term investments in emerging technologies that are going to drive future growth, eventually such financial engineering will be all the industry will have to fall back on, making it increasingly susceptible to activists in what I would call destructive feedback loop. Right, so to sum up, the situation is pretty bleak. It's led to a number of provocative headlines like this one: the chemical industry has lost its future. It has more to do with financial engineering than chemical engineering. But to be clear here, I do think headlines like this are missing some important nuance. So in my view, if the industry does continue like business as usual with playing not to lose approaches, I would agree is very likely lost its future. But just like the Philadelphia Eagles, with the right data and the right insights, I do believe that we can do better here. I do believe there's a way to play to win, and it requires identifying the right tools and the right strategies for deploying them, right? A point that is as pervasive to the sporting world as it is to the corporate business world. And that's exactly what I'll focus on for the rest of this webinar. I'll dive into some of the key technologies that I believe are critical for playing to win and discuss strategies for implementing them and for how to succeed. So I think a good place to start is with the simple question of what makes materials innovations so important in the first place? And to be clear, not just important, but historically very profitable. In fact, meaningfully more so on average than upstream feedstocks and downstream customers. And the answer is quite straightforward, right? Be it traditional things like buildings that we live in, or the transportation that takes us from point A to point B, or electronic materials that enable the Internet of Things. Materials innovations are critical because they enable disruptive products, which makes getting this right, which makes playing to win so important, not just for chemicals and materials players, but for all of their customers across industries and value chains. So in other words, playing to win requires thinking about materials innovations in tandem with the hardware and the software technologies that enable them to create and produce great products. And there's a framework that we use here at Lux a lot to help companies think about how such digital tools are affecting their business, and we call that the digital toolbox. This here, what I'm showing is the digital toolbox as it relates to materials innovations. Now, this list is certainly not exhaustive, and There are many other technologies we could add. But for the purposes of this presentation and the time we have here today, I'm going to focus on 3 tools as examples: materials informatics, generative design software, and 3D printing. Now, I've chosen these 3 because what they all have in common is that they have enormous disruptive potential, not just for the chemical and material industry, but for building and manufacturing products at their downstream customers. So we'll start with 3D printing, which basically is the additive manufacturing of objects layer by layer based on digital design data. Many of you are probably aware 3D printing's benefits are numerous. It allows for parts that are better, cheaper, and have lower environmental impact, and create novel geometries and compositions that are just not possible through traditional top-down manufacturing. Its additive manufacturing processes result in much better materials utilization, and the distributed manufacturing and on-demand manufacturing aspect has really interesting potential to simplify supply chains and logistics and reduce distribution costs. So our models at Lux predict that 3D printing will be a $20 billion market by 2025. But if we really dig into that growth, I think one of the most meaningful takeaways is that we see the bulk of that growth being driven by the increased uptake of 3D printing beyond its roots in prototyping and molds and tooling, and really into end-use parts. There's several technology trends that are really helping enable this shift and driving the increased use of 3D printing in end-use parts, and they include lower part costs from higher throughput printers, lower printer costs, lower materials costs, but also on the performance dimension, better materials and better design software as well, which we'll talk about in just a minute. So what does this mean for you, right? Well, as our 3D printing analysts at Lux would consistently tell you, the key question is no longer, is 3D printing going to be disruptive, or will it come to my industry? The answer is most certainly yes. And you're best off assessing what you are going to do about it. So for instance, leading material companies like DSM and BASF have clearly been thinking about this. And in the past year or so, both have set up dedicated 3D printing business units comprising all of their previously disparate 3D printing related product lines. Others like Evonik have increased capacity for seeing large future demand growth from the 3D printing segment, while others like Mitsubishi Chemical have entered the space via acquisition. And looking down the value chain, we've certainly seen the continued advancement of 3D printing in high performance applications like aerospace and defense. But perhaps most interesting is the increasing momentum in higher volume, lower cost areas like automotive, which just a few short years ago really did seem much further away and has progressed much faster than we actually would have predicted. So to put a fine point on this, if you're not already in the process of developing a 3D printing strategy today, you're very likely already behind, as chances are your competitors already have one. Okay, so the second technology we'll talk about is materials informatics, which in simplest terms is the intersection of artificial intelligence with material science, enabling matching of existing materials with property requirements and discovering new materials. Right, so in addition to the obvious performance benefits here, materials informatics also has the benefits of saving time, saving money, and optimizing the value per physical experiment. If we look at our Lux innovation grid of the materials informatics landscape, you can see a couple things. First, it's worth noting that the space is largely pre-competitive, as most developers are still working to define their business model. But what's also particularly interesting here is that how generally well-positioned most of the active startups are in this space, and you can see this from the positioning our Lux innovation grid here on the left side of the screen. And there's a couple reasons for this. First is the fact that materials informatics complements traditional computational design and is thus not competing for existing market share, but rather unlocking new opportunities to create value. right? And since at heart, this is a software technology, these startups have not had to invest in significant capital expenditure to demonstrate initial value. That said, the biggest challenge by far in materials informatics is a lack of data standards, central repositories, and publicly available published materials data. So the key here, and the thing to remember, is that materials informatics is only as good as the data used to train the machine learning algorithms. And all that data is important, not just from successful experiments, but also including negative and control results as well. And we've actually seen some consortiums pop up over the past couple of years aimed at solving materials informatics data problems. So for instance, at the IBM Research Frontiers Institute, which was founded in 2015, members share results and get to license all institute-generated IP. Advanced materials discovery is one of the key projects here. And just last year, 4 Japanese chemical companies agreed to contribute to basic research to develop a shared platform for materials informatics that's going to be facilitated by that country's National Institute of Materials Science. So the critical balance that corporate players are going to need to strike here is between competing forces of participating in a shared data platform that enables the full benefits of materials informatics against how the sharing of such company data is ultimately also going to benefit competitors. So you can see how it's kind of a twisted prisoner's dilemma situation that companies are grappling with. And I think this is also part of the main reason why a lot of the startups in this space are still struggling to find the right business model. So the final technology that I'll talk about today, and probably the earliest stage, is called generative design, which is an emerging software technology that iterates thousands of cycles to optimize part design based on initial design constraints like material type, weight, strength, and cost that are fed into the system. So to truly appreciate how potentially disruptive this is, it's helpful to think about how historically we were able to design things that we just couldn't manufacture, right? So traditional manufacturing technologies actually had to sacrifice design optimization for manufacturability. But now we have 3D printing technologies that remove many manufacturability issues, further opening up the design space of what's possible. So essentially, you can imagine the pendulum has swung back to product developers to further raise the bar on optimizing design. And to be quite frank, it's my view that when combined with advances in 3D printing and technologies like cloud computing and graphical process units that provide more computing power for running the machine learning algorithms, these synergies are truly pushing the boundaries of what's possible, right? And despite the fact that this still is a very early stage space commercially, it's worth noting that there are a number of startups and large companies working on generative design and relatedly simulation software that could make for potential investment, acquisition, or partnership targets for you. And I think what's so exciting, if you think about the 3 technologies I've talked about here, materials informatics, generative design, and 3D printing, if you think about them all together, I think what's so potentially disruptive is that using such technologies in combination really starts to blur the lines between materials development, product design, and manufacturing, right? Since these are all digital technologies, there's kind of a digital thread that runs through them, and they all rely on software. You can imagine them working synergistically such that there's a constant feedback loop at the material, product, and manufacturing stages to further optimize all aspects of the process. And what's really interesting is it really looks like leading companies, particularly in the 3D printing space, are starting to recognize the truly disruptive potential of the synergy between the hardware and software here. So if you're familiar with the 3D printing space, you're probably familiar with Desktop Metal and Carbon, 2 of the most high-profile and well-funded startups in this space that both currently have over $1 billion valuations. So what's interesting is that while both of these startups gained their recognition, built their brand, earned their valuation, their funding through their hardware technologies, over the past year, both have developed their own software technologies. In the case of Desktop Metal, they've developed in-house a generative design software, and Carbon has developed a simulation software technology. So you can see these leading players are starting to recognize the potential synergy and disruptive potential of combining hardware with software here. So to wrap up, playing not to lose, I strongly believe, is going to doom material companies to a future dominated by financial engineering at the expense of long-term innovation. That is going to be bad for everybody, whether you're a material company or a customer of a material company. This is not a good reality. Unless you're a lawyer or an accountant or financial advisor, I don't think this is the future that we want. That said, I do believe we can do better. I believe we can play to win, but it's going to require thinking about and developing strategies that account for materials innovations in tandem with the technologies that enable great products. And finally, I would just leave you with the thought that, it's not going to be easy. In fact, I think we should all recognize that this is a really, really hard challenge. Playing to win is going to take patience. It's going to take courage in the face of pressure to boost short-term profits at the expense of long-term tech innovation. And it's going to take flexibility and adaptability as these digital tools start to blur the lines between materials, products, and manufacturing stages and disrupt value chains. But I also strongly believe that the potential success, the potential reward here is certainly worth it. All you'd have to do is ask the Philadelphia Eagles. And with that, Rachel, I'll turn it back over to you, and I'm looking forward to answering some of the questions from the audience.
Thanks, Ross. Every time you show this image of the celebration for the Eagles, it just makes me cringe. Glad it's a new season and the Patriots are off to a good start. However, as you're talking through today's presentation, I see what you're talking about, where, having watched that game and the Super Bowl, and what a thrilling conclusion it was to the game, even though it didn't exactly work out the way I, as a Patriots fan, had hoped. The Eagles definitely took a chance. They used that play-to-win strategy, and it paid off, as you said. I have to think that some of the ideas you presented today will also inspire our colleagues on the phone to take a look at their corporate innovation playbooks and maybe revise a few existing strategies or add some new ones. So for everyone who is participating today, we see some questions coming in. If you have any additional questions, please type them into the Q&A box on your screen. And let's get to that first question. So Ross, you talked about startups producing bioperformance materials such as nanocrystalline cellulose and spider silk, making a splash back into 2016, but not showing any results even today. Why do you think so many new materials technologies are failing to live up to the hype?
Yeah, that's a really important question, Rachel. So as I said earlier, one of the benefits, and certainly I'm biased here as a material scientist by training, one of the exciting things about materials technologies is that they're applicable to all industries and they're critical for disruption across all industries. But at the same time, we need to recognize that materials are not end products, right? And the value proposition of a material form factor is not the same as the final product. Certainly the material will be in and enable the final product, but they are not the same thing. And I think too often what a lot of developers do is focus so much at the material stage and developing and scaling the material, and then trying to push that material onto the market, but not having thought about the applications and the value proposition of those end applications in the first place. So I think that's the real difficulty. And what I would advise developers here is to try to think about the applications in which those materials are going to play, and their partnership strategies with downstream companies simultaneous to their materials development, right? And I think also I would just add on that I think what's really interesting, compelling about the technologies I reviewed today is that these digital technologies, they're not materials per se, right? Materials informatics, generative design, 3D printing, they're not materials exactly. They're more like tools that are actually helping to bridge that gap between successful materials and successful end products.
Interesting. So it sounds like it's not just the material. If the material was a square peg, sometimes the company's looking for the square hole, but sometimes a round hole, and sometimes a different shaped hole. If we're
Exactly.
to relate to the old saying. Interesting. So along those lines, you mentioned a number of startups in the presentation. I can think of a couple, Bolt Threads and Spyber, again, who made a splash in 2016, but haven't shown any results to date, likely because of that square peg, round hole theory that you just talked about. A couple of questions have come in asking about how you and your team evaluate these types of startups. So can you walk us through the evaluation process?
Sure, that's a great question. I'm very happy to speak to that. So there's three main approaches that I would point out. The first, most important, that we really pride ourselves on is primary research. So speaking directly with the leading innovators across the emerging technology segments we cover. Startup CEOs, professors, corporate researchers, government researchers. So on a daily basis, our analysts are speaking directly, for instance, with startup CEOs and briefing them and interviewing them about and digging into their core technology and their strategy and their business models and their key performance metrics for their technologies and financial metrics for their businesses. In addition to the insights that we glean from that primary research, we also get our hands on as much innovation data as we can. So patents, publications, government, venture funding, anything we can get our hands on from the data perspective to complement the primary research as well. And then third, we also like to make sure we are covering the trees and the forest, if you allow me that analogy. So if you think of individual company as zooming in on that particular tree, we also want to make sure we have a sense of the forest as well, the overall market landscape that the company is operating in. So we're also making sure we're evaluating it in that context as well. So ultimately, all of our analysis rolls up into a standard scorecard we use for all the startups we speak to, and eventually our Lux take. So we'll tell you what you think you need to know, but we're also going to tell you what we think, our opinion of what it means for you as well.
That is very thorough. I know when I talk with clients at our various events, I hear them say quite frequently that the first thing they turn to is that Lux take, and they really value that in helping make their decisions. So thank you for that overview. So let's take one more question. So obviously the influence of digital technologies on materials and chemical space was a big focus in your presentation. Do you see any other key themes that are impacting the future of materials innovations?
Yeah, absolutely. So certainly I would say that the intersection, as you said, the intersection of material science and digitalization is one of the major themes we're seeing right now. And it's not just at the tech, so this webinar mostly focused at the technology stage, but it also applies to new business models as well. As you can imagine, these digital tools also enabling digital sales channels for chemical and material companies, customization options for consumer products, and 3D printing and scanning, as well as tools like synthetic biology, also allow for right-sized and distributed manufacturing as well. So I would think of the digital tools not just as enabling new technologies and accelerating kind of the bridging the materials products gap, but also enabling new business models as well. But to take a step back and look at other key themes and megatrends that we're seeing affecting the space, one of the other really important ones I would point out is that of sustainability. I think, for many, particularly those who have been in the space, sustainability kind of gets a bit of a bad reputation from previous generations of things like biomaterials and biopolymers that were actually worse or more expensive than the traditional petrochemical materials they were looking to replace. But if you think about it intuitively, the value proposition of sustainability, turning waste into a value-added material, are using less material or energy. There really should be, and I believe there is, a value proposition in sustainability, whether it be reducing cost or actually improving performance in some cases. And I would also add, this is becoming increasingly important as more and more companies have announced, particularly in the past year or so, sustainability and or recyclability goals to achieve in the next 5 to 10 years. And these are certainly going to require materials innovations to be successful.
I see your team writing about the circular economy quite frequently, and I find it absolutely fascinating. As a consumer, look forward to much more innovation and commercialization in that space for sure. So it looks like we're out of time for today. Thank you again, Ross, for a great presentation and for answering those questions from the audience. Unfortunately, we weren't able to get to all of the questions, so if you submitted a question that we didn't answer, or if you'd still like to submit a question, email us directly at questions@luxresearchinc.com, and we will get back to you as a follow-up. If you already submitted a question, we will get back to you either way. You don't have to submit it again. And shameless plug, if you found today's presentation useful, please follow Lux Research on LinkedIn, Twitter, YouTube, or our blog for ongoing information and insights on this topic, as well as many others. And you can always contact us to learn more about how we can help you drive growth through tech innovation for your organization. Thanks for joining us. Have a great day.